Hello everybody, welcome to this CodeRage X session called DataSnap Deep Dive Building Entire Applications. I'm Kelver Merlotti, an Embarcadero MVP in Brazil. I work as editorial coordinator at Active Delphi magazine, also as independent software consultant, specialist on entire and mobile development. I work with Delphi about 15 years and there are my contact information. Today we'll have some fun talking about what's new in DataSnap on RAD Studio 10 Seattle, talking about security features like authentication, authorization, and transport filters, talking about performance and with caching and REST filters, and about responsiveness with callbacks. Let's start with what's new in DataSnap. The first thing to mention is that DataSnap HTTP and HTTPS now don't use indie libraries anymore. They use the native net library of the operating system, and this means that we don't need to deploy the OpenSSL client library with our DataSnap client. Also, with DataSnap and FireDAC related, we have an enhancement on the FireDAC JSON Reflect library framework that are now automatically able to compress the traffic between the server and the client. And a new sample on the DataSnap folders that shows how to use the FireDAC schema adapter component to handle master detail relationships on your softwares. It's a good sample to take a look. Now, talking about authentication and authorization. First, I would like to talk about the difference between these two features because many developers even don't know what they mean. The authentication process is what happens when someone tries to sign in into your server, and the authorization happens when someone already signed in tries to do something. With that said, there's no way to authorize someone that wasn't authenticated yet. And at the same time, if you are authenticated, if you are already authenticated, you still may not be authorized to do something. That's the basic difference. And how do we authenticate a user? On the DataSnap framework, there's a component called TDS Authentication Manager that needs to be linked with our transportation handler component, that it's HTTP or TCP, and it has an event handler called onAuthenticate, and and this event provide three basic information for us. That is the protocol that's being used, if it's HTTP, HTTPS, or TCP, the context that's being used, and the user credentials like username and password. With this information, with this data on your hand, you can decide if that operation is valid or not. You can select your database and check if the user exists, if he or she has privilege to log in your server, and then tell the server that he's able to log in, that these credentials are valid. At the same time, you can tell the server on which roles this user is uh, able to sign in. The roles will help you later decide this which or what the user can or cannot do on the authorization process. By the way, the authorization happens in at least two moments. You can authorize something at least in two moments. One of them is using the trole attribute on over your classes and methods. Just on the line above, you can put on the TRollout attribute that says which roles can and which roles cannot use that resource, that class, or that method. And also, the Authentication Manager component has a collection called roles where you can specify each method or classes are able or are allowed or are denied to use your server. One important thing to note is that the TDS Authentication Manager roles collection will override any TRollout attribute that's in your code. So let's see authentication and authorization in practice. So here I have a server, a DataSnap server and DataSnap client. On this server, we have a server container that was generated by the DataSnap server wizard. And here is the main component responsible for the security of the DataSnap server, the DS Authentication Manager. On his own user authenticate event handler is where we can check, we can test if the user credentials are valid or not, and assign to this user a role. In this sample, I am calling a method, a class method called valid user that is implemented on this data module with just a FireDAC connection and a query that selects from the employee table the number of the employee and his job code, considering his last name as username and his phone extension as the password. So we have a class method here that receives the user and password, pass to those parameters its values. Then we open the query, and if this query isn't empty, the user was found and it's a valid user, then we will return valid through as the function result, and also the employee number and their job code. Back to the server container, we will receive these three information that if it's valid or not, his ID and his role, and if it's valid, if it's a valid user, we will register his ID on the session and test if the role this user has is one of these selected roles to be an admin. If this employee doesn't apply in any of these job roles, we will assign to him the user profile. And now that we told the server that he's a valid user and told him in each profile or in each role he's assigned to, we can authorize this user when he tries to do something in something special, let's say. And to demonstrate this usage, I define it here on the Authentication Manager on its roles collection that all the times all the times that a user calls an applyPdate method, only the admin's user or only the users that were assigned to the admin role will be authorized to do this applyPdate. So users profile will never apply updates, only the admin ones. And beyond that, on our server methods that has just three methods, the two generated with the wizard, the equal string and reverse string, and a new method called get salary. This method will only be able to be executed by admin users. So if any employee that were assigned to the user profile won't get to execute this method. Let's run the server and take a look on the client. Here we just make a connection to our database DataSnap server using the user credentials that was inputted here, and we have the possibility to execute the get salary method through the SQL Server method. Here is the method we're gonna call. Also, we can get the customers, opening the client's data set and try to apply those updates that will be able only to admin users. Let's run the client now and check if it's working. First, we will log in with a user that are not on those selected jobs. His password is 6. Now we connected. If we try a different password, it won't connect. It will reject the user credentials. So only the specified users that on the database active will be able to log in on the DataSnap server, and just those authorized users will get the salary. You can see that he can't perform the requested action, and also this kind of users won't be able to change the data. He can change locally, but when he tries to apply the updates, it will fail again as he is not authorized. If we connect with some user that is on the admin role, we can get the salary from any employee. We can execute the get salary function. We can change the values of the data and apply the updates without any problems. That's it with authentication and authorization. More about authentication and authorization you can see on those links that will be available as soon as possible when CodeRage X ends, and all the materials will be available. Let's continue with transport filters. So what a filter is that? A transport filter, in summary, is a code, or it's your code, a custom class that will be executed over the bytes that will be sent and received by the server and the client applications. So it's a way you can manage or monitor everything that is transferred between the peers of your application. And RAD Studio brings 3 built-in filters ready to use. They are one compression filter based on zlib and 2 encryption filters based on RSA and PC1. All these filters take effect only with TCP transportation, and both client and servers need to have the filter declared. Also, filters can be customized, extending the tdbx transport filter class, the transport filter class that on the dbx transport unit. On the documentation, we also have a new material, even step by step of how to create a filter. And now we have about, we'll take a look about filters in practice. Here we're using the same server and client from the other sample, from the authentication sample. And what we need to do to enable the filters are really simple. On the server side, we need to go to your TCP server transport component, and on the filters collection, you need to add the filters you want. Here, I added the compression filter on our server, and on the client side, did the same on the SQL connection component. If we expand here the driver properties, we also have a filters collection where we need to specify the filters we are using. So here I use the same filters, and another important thing to remember is to add to the use clauses of your unit just in one of your unit the dbx compression filter if you're using the compression filter as in this example. Now if you run the server and the client, we can do that everything works on the same way. Here we go, connect to the user, get the salary, and get the customers, and go on. But I used an application called RAW-CAP that monitors the traffic over TCP/IP, the local traffic of TCP/IP, and got these two files. And I would like to show you first the file with where when the server wasn't with filters. There was no filters on the server and client, and on the method that was called to get the customers, it had to execute two times two fetches from the server, one with this length 1460 plus 761 bytes. It costs two fetches to get the data, and when we enabled the filter on the client application, the same request could be done with one single fetch of 1400 bytes, so almost 800 bytes smaller. So it's really a nice feature that's built in and ready to use with DataSnap. More about transport filters you can see on those links that, as I said, will be available as soon as possible when CodeRage X ends. Or if you want, mail me and I'll send you. Now, talking about caching. Well, think about it. Is there anything faster to process that what doesn't need to be processed? I'm sure there's not. So that's where cache makes sense. And DataSnap has an interesting feature to be used with REST servers, mainly when you're using non-Delphi or C++ builder clients that are REST parameter caching. In summary, when a method returns more than one or more complex types like streams, it can tells the client that those data are stored in cache, and then tells this client how they can get this information. So at the first time, it will answer a content like this. That means the IDs of the method, cache, and parameters. So the client can make another request like this here and ask the server to give him back those information that's on the cache. And not so DataSnap related, but in a more conceptual way, I think you should think more about caching data. It's almost always a good idea. I know it's not so easy to do, but in your production environment, it's still valuable. You can do it in many ways on the server side, on the client side, that in my opinion, it's preferred on the client side. Data that don't change often are really good candidates to be cacheable, like a list of countries, states, cities, measurement units, and so on. Every kind of data that doesn't change often is really a good candidate. You need to take a look on this idea. Of course, it's really important to have an invalidation mechanism so you can tell the client or the client can know itself that that data that it has on its hands isn't valid anymore, and then ask again for new data. This kind of invalidation process can be done in many ways, but generally they are made by lifetime, setting a date and time to that cache expire, and also about the data change using a hash of the cache. You can calculate a hash of the cache you have locally and ask to the server if that data is still valid or if it's changed, or even with the version control of your data. And Interbase has a really nice feature called change views that is perfect in these scenarios. You need to take a look on it. About the cache on the client side, it's important to mention that it's preferable because you'll avoid unnecessary traffic to your database server, to your application server, and hence to the database server. So you will have a really shorter way to get data. They are local, and for sure it will need more attention. It will need more to need take care about invalidating those data that you store locally. You can consider using client datasets or FireDAC memory table to store this data in an easy way. You can just call the save to file, for example, and have the data stored. And another interesting thing you can use to navigate in your local data is the FireDAC local SQL feature that will help you to do queries over your local data. And remember, on one important thing to remember. In most cases, you don't need to synchronize your cache. It's a waste of time. Just drop it and create again. Not in all these cases, but in the most cases. About a cache on the server side, it allows us to avoid unnecessary database access. That is also a good idea, but less helpful than the cache on the client side, in my opinion. It can be done using two ways, in two ways, using one single cache to all the clients, or a per client or per session class cache. If you decide to do a single cache to all the clients, you can use you can use the life cycle property of your TDS server class to tell the server that that class will be a single instance in all the server. This makes more sense in all the cases, but it's not always possible. You might you may find some troubles implementing this in some cases. And if you use the session lifecycle, each client will have your own cache. Let's take a look at the caching demo. To the caching demo, we created a DataSnap REST server application, and on the server methods unit, we added two methods that returns one image as a stream or two images as a stream, one in the result and the other on a out parameter. And to test the parameter caching, we'll put a breakpoint here and run the application and test it on the browser. Let's take a look here in Chrome. We have a debugging tool that is activated with the function 12 key, and I also have a tool that's called change HTTP request reader that enables us to make some changes on the headers that are sent in a request. So first, what I'll do here is to call the get image method, and we can see here that a session was opened in our DataSnap server, and this is his ID. The response was the image, the single image that we got. If you need it as a JSON, you can put this parameters on the end of the URL, and it will give you an array of bytes in the JSON format. Now, if we get the get images method, but before it, I'll make some changes. First, saying the DES session ID and the pragma header as the DataSnap engine requires, to tell the server that this request is on the same session that the request made earlier. And on the accept header, I'll tell the server that I want application slash rest content. When I do these changes on this change on the reader, on the request header, I'm telling the server that he's able to cache complex types. Now, if I do execute this request, it will execute the method Now you can see that the breakpoint was activated. And back into the browser, we had two we had a download file because it was in a stream, but we don't want this content. We want the cache content. Now, if we change the URL to this one, we'll have an image, and take a look that the breakpoint wasn't enabled, so it was not processing our request. It was getting the value from the cache. Okay, so here it is, the REST parameter cache of DataSnap working. Now, the other part of the cache we talked about was data, cache of data. And what I did here was to create another server method descended from the data module. And this server method, I just dropped a SQL FARDAC connection and the FARDAC query listing all the countries from the employee database, and the method countries returns a data set. What I do is if the memory table is not active, I open the query and copy the query data set to the memory table and result and send as result this memory table. So the next request to this method will not open the query again because the memory table will be active and will only send its content again. So if we open one client to this application and get the countries, the breakpoint is stopped, the query is open, and the data is copied to the memory table and returned to the client application. Now I'll open another client and get the countries again, and look that the breakpoint wasn't enabled because the memory table is already active and his content was sent. This is a kind of cache from the server side. We had an instance, a single instance of the server method that this was done using the server class lifecycle here on our server container. In this case, in our web module, I have another server class which lifecycle is server. It means that only one instance of this server method of this data module will be available until all the life of the server. No matter which client requests, it will have get the data from the same source, from this instance of server method. Then we have a cache in the server side. But what I also did is that when the client gets his data, it saves locally its data. Here it is. And this means that even when the server is not running, but we get an instance of the client, we can get the data. It's there, it's locally. We don't need to go to the server. And come on, how many times this kind of data will change in years, isn't it? So it's totally possible to store this kind of data locally, and sometimes to check if it's necessary to update your local cache. The clear cache just drops this local data and will force a new fetch from the server. In this case, it failed because the server is not running. If we start it and try again, we probably will get the results. There it is. And let's just, before I finish, take a look in the client side how it was done. It's really simple. On the get countries button, we test if the file exists and load the data from the file. If not, we calls the countries method from the new server method we've created and copy the result, the data set that it results to the memory table. On the clear cache button, it's just to delete the file that was specified in this constant. So it's just an idea to make you think more about cache or data. On these links you can find more about caching, specifically about parameter caching, that it's a DataSnap REST feature. Now let's talk about REST request filters. In summary, the REST request filters are more related to REST than DataSnap itself. And if you're not familiar with REST, you should start studying about it on this link, for example, restapitutorial.com. In summary, REST servers generally has a way to select from the content that will be sent to the client which part of it will be sent. And this is called REST request filters, a way to filter, to select from the content what will be sent. They're used at the end of the URL, like this example. After the method and parameters, you can put a question mark and the filter dot the function equals the parameters. DataSnap has two built-in REST filters that are substrings and tables. The substring filter can operate on strings and its characters or on streams and its bytes. It has three functions that are count, offset, and range. With count function, you can tell how many characters from the first, starting from the first characters you want to return. The offset, how many characters you want to skip from the first. And the range has two parameters to tell the count and the offset. Really useful to do a kind of pagination. The table filter has the same three functions, but they operate over the records of a table, of a data set. So you can specify the numbers of records you want to send to the client, starting from the first, using the count function. You can tell the server which records you want to skip sending to the client using the offset function, or using the range function. You can tell both things at the same time, telling the server from where do you want to start and how many records do you want to send to the client. Let's see request filters in practice. To this demo, I created a DataSnap REST server that has mainly two methods. They are the echo string and the customers method that opens a query and return it to the client. Let's run the server, and on the client side we have At the top, a way to test the substring filter, remembering that the substring is also applied to streams. So here we can test over characters, but you can also do the same with the bytes of the string. For example, the count function will return the first 5 letters. First we need to start our server, and then echo string the first 5 letters. If we use the offset function, it will skip the 5. And if we use the range function, for example, skipping 5, getting 10, it will get the 10 letters after 10 characters after the first 5 characters. And with the customers, with the data or the table filter, what we did was to specify the number of records per page, and when we get the customers, it is filtered skipping at the first page no records and getting 10, count 10. The next page it will skip 5 and get more 5, and the third page skip 10 and get more 5, and so on. This was done using this property current page and the get data method. This get data will get the filter accordingly to the page, so we get the count from the spin edit, and the skip is based on the current page. Then we will create this filter, and the get data method will call the customers method passing this filter to the server. Remember that when using filter, you are still loading all the content in the server, and after load it, you will filter what goes to the client. So pay attention on where and how you use the filters. You can find more about REST request filters on those links that point to Embarcadero documentation and to the RAD in action event that happened some times ago. Now let's talk about callback. And what is callback? So let's think about it. When you call someone, he or she can call you back, right? That's what a server does. If a client calls a server, this server can calls back this client. Okay, but why? Well, it gives the server the possibility to talk to the client in a proactive way, so it doesn't need to wait a request anymore. It can, in a proactive way, talk to the client. For example, when a client requests something to the server, when we make a request to the server, we don't know what's happening there until this request is processed and the response comes to the client. On the other side, the server doesn't know. It doesn't have any idea about how to tell the client what's happening. It only knows that he received a request. It will process this request, and when it ends, it will send back the response to the client. If you tell the server that he has a way to talk to you while it's processing your request, he can update you about the process. Hey, I'm doing the step 1, I'm doing the step 2, I'm doing the step 3. Hey client, here you are, here you go, your response. And many things would be responsiveness. Great, but how do we do that? Using a callback method or a callback channel. Let's see in practice. To the callback sample, first we'll take a look at the callback method. Here I have a button that calls a method on the server called generate report, and this method has an interesting parameter that is a dbx callback, and that's the key point to the callback method. Here we can tell the server how it can call us back. We will send a structure that the dbx framework implements to to give the server the ability to send us some JSON value, and when we receive this JSON value we will call the update progress method, passing to it the value. And the update progress method will only use the synchronize thread method to update the label and the progress bar here on the screen. And while the main thread will be busy waiting to this response, the server will be sending us the feedback about what is he doing, and we need to do this in a thread method using the synchronize. So on the server side, what happens is that on the generate report we simulate uh, a process doing a for from the start to the end and waiting to it, and on each step we create a status that is a JSON object and add one value to this object. In this case, only the step we are, only the number of the step we are. We could do many values as we want here on this callback method and just handle this data on the client side to update your screen. But now only we need is this feature, this implementation. The client will send the server an object away, a callback object to tell the server how it can call back the client. So when we get the report, at this time the main thread is busy waiting for the report, but the server is sending us back the feedback about what is it doing, and then we can update the progress. This is how the callback methods works. Now let's take a look about the channel, the callback channel. Uh, on the server we don't need anything else, anything different to implement a callback channel, because everything we need already is already on the DDS server. For example, if we get its name, we can see that we have the broadcast message, for example, and here you can pass the callback name. But on the client side, it's where the key point appears, because although the server could talk to the client, first the client needs to tell the server how to talk to him. Here we saw how to do this using a callback method, and to create a channel to a server with a server we use this component, the client callback channel manager. It has two main properties that are the channel name and the manager ID. Then we can on create event we can generate a name to this callback and a name to its manager. Now the channel manager component can register a callback using these IDs, using the callback name and mainly the process, the object that will be used to this used by the server to send the content. That's the same object we used on the callback method. Just in this case, it's just a simple example. Now, with that said, when we register a callback, it's like we have a way, an open door between the server and the client. And if we have more opened clients, they could talk with the server and broadcast message. For example, let me connect this and this client, and I wanna send this number to everybody that's listening to the channel. And there you go, they're listening it. If I send a number less than 10, that the max of the progress bar at this time, it will work. And another thing we're able to do is to send to a specific client. So if I get these credentials and say and send a different value to this specific ID, only this client will receive. Otherwise, if I send some value to the entire channel, everybody that was registered in this channel ID will receive that message. And this is the callback channel. Now let's get back to the presentation, and you can find more about the callback on those links. And I would like to mention that it is also possible to have heavyweight callbacks using HTTP connections. And here are the materials you can read about and watch to implement heavyweight callbacks using HTTP connections. It's a really important thing to be aware of. And that's it by now. Just to finish, please explore the DataSnap features. They are there to use and they work fine. Take a look at the samples that are on the your documents publicly, probably on your documents, your public documents. If you didn't change the setting on when you install your Delphi, study those samples. They are a really good source of knowledge. Uh, Wizards will never give us the best results. Go further, try to understand what the wizard does, try to start something from scratch, try to comprehend what each component is doing in your application. It will allow you to have more control, to find problems easiest. So study beyond the wizards, and always plan your server thinking, considering your deployment scenario, your production environment. Even the network quality should be considered. For example, if you have a unstable network or a really slow network, you won't have success using TCP/IP communication. You should go with REST over HTTP. Also, read about database connection pooling and use it. FireDeck has a really easy way to implement connection pooling, database connection pooling, and it can grow your performance and your response time. Some database engines support this feature, this kind of pulling right on the engine, the database engine, but FireDeck and DB Express also have their way to implement connection pooling. So take a look on it. And remember that lightness is never enough. Science our goal is is the best performance ever to be as fast as possible. But only heavyweight efforts will bring lightweight results. Thank you guys for now, and feel free to stay in touch. Let's go now to the live Q&A.
All right, fantastic. Thank you, Kelver, for that session. Lots of, I love these deep dives that cover lots of stuff in great detail like you did there. So fantastic. It looks like you've been busy answering questions already, so that's good to see.
Yeah, I tried to answer all the questions during the session, even because the content was too long. I would like to sorry you for this, but I prefer to use the time with showing all the content. But I will be here for a few minutes yet, and I'll try to answer those questions that I didn't answer yet. So by now, that's it. Thank you very much for this time. I really appreciate it, and I hope to see you all soon.
Okay, fantastic. So let's go ahead and if we can recap a couple of these really quick. I know we're out of time, but just was there anything particular that you'd like to add, maybe, or any questions you thought were particularly poignant that you'd like to bring up and talk to her about right now?
I can add those questions to the presentation.
Okay, well, here's a question: is it useful to cache on both sides?
Yes, it is. The cache concept. In fact, it's more related to the context that the application is running. Sometimes it's more useful to have only on the client side, in others on the server side, and in some cases on both sides. So there's not a rule to follow. It's not one way to go. You need to analyze the context and then decide what to do, but it's totally possible.
Okay, excellent. Filters are available only with TCP/IP transport. Is that correct, or do they work with HTTP as well?
Yes, as far as I know, they work over on TCP/IP. I never got good results using HTTP, so that's why I said it. And maybe I'm doing something wrong, but I always use it with success on TCP/IP transportation. That's it.
Okay. All right. Well, fantastic. Thank you, Kelver, for your time. I'll let you go ahead. There's a couple of ones here I'll let you type out that are pretty specific, it looks like.
Okay. Thank you again, and hope you see you soon.
Thanks. All right. Bye.
Bye bye.